So, hello everybody. Let's switch to our program. And welcome to our webinar. Today we will talk about some hidden problems and aspects of performance testing on JavaScript of your backend services. But before we start, I need to tell you that today we will not cover some very important types of testing like client-side performance testing, where we measure some web pages, load time, and performance. This discussion would be more focused on the aspects of the backend performance testing, which is much more challenging and has a lot of hidden rocks. I hope that my experience will help you to make a correct decision when setting up the performance testing process on your project. And most of the time, we will spend around writing performance tests on JavaScript and TypeScript, and how to choose a correct solution to make your backend faster and your life easier. So let me to tell a few words about it before we start. I will tell some few words about me. So exactly, this is me the last week. Yeah, this was a very funny moment when I wanted to create this material for you. So I was like in the center of the hurricane, but I am very glad that you were joined this event, and let's start with introducing myself. A few words about me. My name is Savva, and I'm a senior performance engineer at Svitla Systems. I have at most 4 years experience in performance testing, building different performance testing solutions using various languages like Scala, Java, Python, JavaScript, and TypeScript, and also on different CI/CD, using different CI/CD environments. The latest years, my performance testing experience was connected with a grounding up and creating a performance testing solutions from scratch, with underlying my place in the team and sharing the culture of the performance testing to all the team members. Let's switch back. About the performance testing. While thinking about the performance testing, we should know that it has a lot of goals and definitions. And in general, we can define the performance testing process kind of like a non-functional kind of testing whose main goal is to check the system behavior under the emulated load. In this webinar, we will try to break out the beginner stereotype about the performance testing. That's not just getting a performance testing tool with a goal to hammer some random endpoints or to make a DDoS attacks. As there are a bunch of console applications and benchmarking console tools like Slow Cooker, Siege, Bombardier, which are lightweight and can be used by the most of the developers who are experienced in bash scripting. Instead of this today, we will cover some more important things about the performance testing process and tools that are able to save your time and to save you from the potential problems and money losses. Also, as you can see in this presentation, I will use more than 2 or 3 times such definitions like load profile, which means it is a document which describes the requests or hits statistics, the main business flows, including the exact number of requests in each that should be made, and how frequently one scenario should be used comparing with others to emulate the production-like traffic. And also the second definition will be load plan. It is the description of how the main test phases like ramp up, load, cooldown are going, and the type of the workload model, open or closed. So as mentioned earlier, there's sometimes performance testing can be interpreted incorrectly, and the whole performance testing process covers a lot more things that need to be prepared before the test design phase will start. Otherwise, there is a huge chance to go into the wrong direction and to get absolutely wrong metrics and results. In general, the performance testing process includes such phases like requirements investigation, and includes developing a non-functional requirements, getting a product owner's vision about how the product does, how many concurrent users and requests the system should handle, and also your test exit criteria. It will tell you what are your goals and where are you going, how the downtime of your application costs, and how to prevent it. The second point is system investigation. Without investigating the system or component architecture and protocols, you will not be able to choose the right tool. Monitoring preparation. I could not imagine how to analyze the test results and make the test report without application side monitoring. It's unbelievable to make any decisions without it. Developing test strategy and test plan will help you to show the roadmap, test levels, how the performance testing will be done, and some future plans about your test architecture and about your solution growth. The developing the load plan, the load profile gives you a confidence why they are so important. They gives you confidence in your test results. Without it, you will not be able to predict the future problems and bottlenecks and make a correct mark of the resources capacity. The scenario development, it is what we will discuss today. We will focus more on this point. Data preparation. It is a very important stage where we try to fulfill the database with the right data and with the right format, generate needed snapshots, making a correct test scenario parameterization. Test environment preparation, mostly done and deployed with the DevOps engineers or developers or by the QAs. Mostly about the QA deploys I met various such cases very rarely. They are very rarely used. Mostly QAs asking the DevOps engineers to help them to deploy and prepare the test environment with the needed configurations. And also at the end, we have test execution and results analysis and reporting. So as we can see here that the phase of the scenario development is just a little part of the whole process, and mostly the process of performance testing is about architecture, monitoring, and DevOps process, but not about framework development and coding like in the usual functional testing. So I need to share with my experience how I came to the JavaScript in performance testing and how the progress and main trends are changing everything, setting a new, much higher standards for existing performance testing frameworks. So how I came to the JS on my current project in the global AD. Before we start, I need to tell you a short note about the global AD. It is a product which lets people create their own digital identities using their biometric data, passport or license data, and to use them in every aspect of their life as an authentication system or to control their finance life. So the biggest reasons why I decided to start developing the scenarios on JavaScript were like the most of the services. When I came, the developers told me that mostly maybe 80% of the code base and services were written on JavaScript and TypeScript. Also, the API integration and system tests, which describes the main business flows from the APIs, are written mostly on JavaScript and TypeScript. The project have the crypto wallets and different security libraries and developer libraries written on JavaScript and TypeScript. Also, the encryption is used everywhere in these projects to send the encrypted password, where I'm sending every time encrypted passwords, hashes, digital signatures in all my API calls. And the last reason about why I use JavaScript also, sometimes I tired from OOP and creating a huge cascade classes or models generation using open API specifications of your services. So JS makes everything much easier. So going back to our topic, the most of our discussion will be around tooling and technologies that helps us to be more successful and fast with developing reliable scenarios for emulating real production traffic. In this tool list that I choose here, that I will show you now, I included the best tools of the modern performance testing framework, which satisfies such criteria like to be open source and free, to have an ability to run on any CI/CD environment, to be integrated with the most popular monitoring tools like Datadog, Grafana, CloudWatch, also Azure, also and many Influx and many others. So they also should be an extendable and useful by the developers. And the leaders, by my opinion, are first one is Henchevskyi, is maybe the most widely and popular tool, not the most widely used one, and the popular with maybe the most oldest one, and it have the most biggest community now. So the second one is Gatling. Also, one of my first one when I started writing the performance tests, I started from the Locust.io. And so our next candidates, today our talk will be mostly around the K6 and the artillery, which also which support writing test scripts on JavaScript. And they could be easier integrated with our JS and TypeScript technology park, according to the reasons that were mentioned earlier in the previous slide. Let's take a closer look to them. So before we start the demo, we first we will make a very short comparison. Here is the table. In this table, I didn't include the comparison of all the features that these instruments have. From the other side, there are a lot of similar facts about these tools. In this table, I try to show just the most critical key points that need to be considered when choosing a tool from the QA's perspective and from the developer's perspective. Both tools are open source and have enterprise class solutions with different deployment plans. They both support JavaScript. TypeScript could be used just by K6. I think that's not a very huge plus for the K6 because all the TypeScript code need to be recompiled using a Webpack into the same JavaScript file that should be executed finally. But for other side, it adds a bit more synthetic sugar to the scenarios. Both tools have support of the big variety of monitoring tools such as Datadog, Prometheus, Influx, StatsD, and others. Both of these tools are extendable and gave the developers the ability to extend the tool functionality to support custom protocols. But the minus of the K6 here is that the most of the K engineers don't have an experience in coding on Golang, under which the K6 is developed one. K6 have a larger community and more extensively growing. As I said, yeah, the K6 are written on Golang. It means that this tool is more lightweight, maybe it is 3 or 5 times lighter than artillery, but it takes less resources and the less CPU resources and memory too. But K6 have more plugins and protocols supported rather than artillery, but that's not a big disadvantage for artillery because artillery also has all needed plugins for testing the HTTP APIs, GraphQL, WebSockets. It also have a Playwright plugin to test to execute our scenarios and parallel users in the browsers, which covers more than 19% of all the needs, all the developers' needs. And also it can be extended using any clients and protocols from any Node.js libraries. So it's extremely hackable. Finally, what I can say about the documentation, both of them have a beautiful documentation, but there are some documentation gaps for artillery because there is a chance to find some old information sometimes, and some cool features of their instrument are not well documented and can be found just from other repositories or examples. So I named this battle like stability and popularity versus hackability. And in the next demo, I will show you why the hackability and why the artillery is much more flexible than K6. So let's start from the short demo. In this short demo, I will show you some project which runs on the GitHub Actions. Actually, this all demo project I set it up in the GitHub. They are have its own jobs in the GitHub Actions. Also, the needed load agents will be set up in the Docker containers in the distributed runners that are distributed from the GitHub, and also at the same time, at the same virtual machine, we will be running another container with a Datadog agents, which will be getting and gathering all the metrics from the both load generator tools, and also we will test some sample mock APIs that will be just a slight emulation of REST APIs. And also all the metrics will be reported and published to the Datadog I have two separate dashboards there. With I added some sugar to them, and also these dashboards also will be available in the demo projects. So after the webinar, you will be able to get those dashboards and to use in the real practice on your projects. And so, as you see, we will start first from, I will stop sharing the presentation, and then I will try navigating to the project with K6 TypeScript demo. So first we'll start overviewing the K6. So I will not cover all the aspects of the K6 scenarios development. I will not show you all the features. It will be very boring to show how and to go through all the documentation of the K6. I will show you slightly how the K6 scenarios look like, and after that I will show you in what cases K6 fails and in what cases K6 does not running and could not be used in your projects, and why you should be careful with it. So first, in this example, I have some load test scenario in here in this repo with the name K6 TypeScript demo. And also I have two types of the scenarios here, some post reader scenario and post writer scenario, and how they look like. So the scenarios and writing the K6 scenarios are very smart. So you could enjoy the writing the K6 scenarios because K6 lets you to do everything that you want out from the code. So also the description of the HTTP calls that is presented in this example. We're mostly testing some endpoints, and also the endpoint description could be smart written, and also it can have its own fluent assertions like I wrote here. In this example, I wrote a bunch of fluent assertions to be added like in a chain in the end of the HTTP call. All the sources will be available here. But mostly the reason why we came here is not with learning how to write beautiful scenarios using K6, but to get to know in what case you should be careful with using K6. So as I said earlier, that on my project, I have a lot of crypto libraries and security libraries, and also I have crypto wallets. It means that to test fully your APIs, you will be using some developer libraries, which are using mostly the very well-known crypto module, where we have the native Node.js crypto module, which lets you to create on-the-fly key private and public keys to encrypt the data, to decrypt the data, to create digital signatures, and which are used to encrypt all the data. And also we will try to emulate the real world case that I had on my project, because first of all, I just were focused on the K6. I was trying to add this crypto library to my dependencies. So in this scenario, we will try to emulate the same stuff. So here is the default method that describes the scenario. So it have a sleep of 1 second. So after that, we will try to print out the start. After that, we will try to generate the public and private keys. After that, we will try to create a signature, a huge hash, which encrypts some test data, and with using all this private key. So and let's encrypt here some. By default, I'm encrypting the data with name test. Like, let's try to encrypt some another data with name hello world. And let's try to understand how the K6 does this all these tasks. So first of all, we need to add the node crypto library to your imports here. So the K6 does not allow you to add the crypto library like an usual ES import. You should use, it allows you just to use crypto module from the required definition. So after we added the crypto to your, after we added the external JavaScript module to the K6 scenario, it means that this scenario should be compiled by the Webpack. So I already have the Webpack configuration for that, but I will comment this out because this is a real world case. So first of all, we have this scenario which just creates a keys and creates a signatures and print out the signature to the console. We will try to build this crypto test scenario using Webpacks. First, let's try to do that. After that, so we see that he throws a lot of different errors. So he failed with compiling this code. He shows that we should add some polyfills and we should add to the Webpack configuration some resolve fallback for some libraries that also should be added. I added them. So to fix all the problems, we should uncomment that code I commented in the Webpack config. So let's try to rebuild it again. And we could see that we resolved all the issues. Now you can see that all these files have been built, and also we see our cryptotest.js file in here. So let's try to run the cryptotest with K6, and let's see what would happen. Oh, it fails. And what is well, let's see what error it throws. Object has no member like generate key pair sync. So I don't know what could be the problem, but seeing the Webpack built this module incorrectly, so it doesn't have some methods and it doesn't work for us. And in my case, when I added those developer libraries to test the APIs with this encryption, also I was failed, and actually after resolving all the errors, it came to nothing actually. But we also have one different way. So I created another two methods, which are thus the same using other different libraries that could be joined to the K6. So let's command this generate k pairs method and create signature method. And let's use here generating a hash using Node4j library. So it could be also used to generate RSA keys and different other types of the keys, and after that to encrypt the data and to create digital signatures. So we have the same methods with the same names, so we should not change anything. So they are here. So let's try to rebuild our scenario again with a Webpack. So I also was already resolved all the errors that were happening. So the building of such scenario also was fixed. And also after that, let's try to run those scenario with that Windows was not defined. So let's uncomment this global. Let's set the global window variable. And let's repeat again what we made. So let's build again with a Webpack. And let's try to run the crypto. Now the scenario starts and seems nothing is happening. So seems the code is valid, but not. And we will not wait till this code execution will end. So it will the duration of the execution of these methods, for example, it takes nearly more than 1 minute to execute this method and more than 1 minute to execute this create signature method. So we will not try doing that. We will not wait till the end because we don't have so much time. But yeah, you can see that something happens when the K6 builds all these scenarios with external Node.js libraries, which allows us to generate those hashes and create these digital identities. But actually, the K6 have the crypto utility for that. I know the K6 have such method to create hashes and to encrypt some data, but they don't have closely such variety of methods to create RSA keys, to work with those RSA keys, and to encrypt the data and to create digital signatures and to sign the data and to decrypt and encrypt the data with the right way. So that's why we were not able to do our work with a K6. So, but let's take a look at the artillery project. But before that, we will try to return everything back. And so we will try to navigate to the project with a K6 to run the sample with a presentation to run the sample scenario here. So here we have the K6 demo project, and actually here it is. In the actions, we have such action like performance tests. Also, everybody could try that. Now they will, after they could find this public repo, they could enter into here and they could try running this GitHub Actions job by themselves. GitHub Actions adds a lot of interesting sugar for running the performance tests with the different parameters. And actually, let's run those actions. Oh, actually, seems we don't have an access to you. Then I should sign in. 1 second. I should rebase to another type. So now we are here, then we will try to run this to enter to this GitHub project. K6 demo project. Let's go here. Let's go to the performance test job and let's run the workflow. So we have here, we are running from the master branch. We are running the load scenario that we overviewed in the last 5 minutes. So let's run those scenarios to see at the end what we have there, what metrics we have in the output to the and how we can also build beautiful graphs and dashboards with Datadog using the K6 metrics. So, but when this load test will be running, we will navigate to the second project to overview all the features of the artillery. So as we can see here, I have the TypeScript demo project. So 1 second. So we are going to the artillery POC. This demo project is designed to show you all the features of the artillery. As we remember from the last demo repo, that we were not able, with the K6, was not able to do some digital signatures for us using private and public keys. So we will try to do the same stuff with artillery. At the end, I will show you all the features of the artillery and to show you why the artillery may be one of the most underrated frameworks on the market, because it had not so much descriptions about the best features and how what flexibility it allows you to write. It gives you freedom to do everything, any crazy idea. So first of all, I need to show you how artillery does the same task like the last K6 solution. So here we have the system scenario. So artillery mostly uses YAML format to describe all the scenarios. And in this scenario, we will try to print out the signature function. And all the functions are described in the separate JS file. So the print signature, we could see that we have here the print signature. So the main difference between and the biggest advantage of the artillery is K6 is not allowed to work with all Node.js libraries, but artillery does. So it could aid, and you could join any Node.js library which supports more than the library which could be supported by Node.js 16 and bigger. So we are seeing here the same create signature and generate keys methods. So we will try to execute the same functions with artillery and to see how the artillery works. Actually, here I already have been prepared some methods that execute this debug job for us. And let's see how artillery does that. So it's not matter why we should don't wait for the end of the scenario. We can see that it prints the signature for us. It means that artillery is extremely hackable and also could join to it dependencies, any Node.js library, any Node.js module, any developer library on JavaScript or TypeScript. And it also could use it in its own dependencies, its own scenarios. And in this case, there is no any problems when generating a keys, when creating a signature, and when printing out the signature to the console. So we could use those generated signature and keys in our tests and scenarios, and without any problems. So this is not the biggest advantage of the artillery. We will not, but also artillery is well known by its many other features. So mostly I was showing you that the artillery is using the YAML keywords, and the keywords that are written to the flow section in the scenarios. We can describe here the HTTP calls, some WebSocket calls, and many others. We could also group together a few scenarios. Here I have the same post reader and post writer scenarios, like in the K6 project. And but the biggest minus here, then you could not reuse some pieces of YAML files or codes besides using some YAML templates. So this could be a very big disadvantage. And mostly K6 is extended, this YAML scenario is extended, we could say that, by the JavaScript functions, like this one, to execute some functions before request, to execute some functions after response, to execute some functions in between of the HTTP calls, and to do some things with the user context. And also the biggest advantage comparing with the K6, what do we have here? The K6 is extremely hackable and extendable. Why extremely? Because in artillery, we can see here the configuration description at the beginning of the scenarios, and we have here the YAML description of the whole scenario. But in the K6 allows you to get access to everything. So with the K6 plugins, you are able to access all your configurations. You're able to assess also not just the test phases, also you are able to assess your ensure thresholds and all the metrics that are output every 10 seconds in the console, and to get to control all the life cycle of your scenario. And also K6 allows you to write some new not K6, sorry, it's artillery, allows you to write extended, to be extended with the engines. It calls engines, but it is actual implementation of the protocol. So you could artillery could be extended with, so artillery could add any library, Node.js library, and with this Node.js library could be used to create a new plugin, a new protocol for artillery. And in this example, I have in this demo repo, I have some example of artillery engine implementation in JavaScript. So artillery allows you to extend the tool using JavaScript, not Golang, like in K6. So the code of custom engine implementation is a little bit complicated, but it have a very full freedom to create the new scenario from scratch. So where is this scenario that I implemented, this engine scenario? So artillery allows you to use JavaScript to create your own protocols and to create the new descriptions of your scenarios. For example, I created my custom keyword like flow function in here that would be executed every time when my scenario starts. So, and I created my custom flow. So in this my custom flow, I created my custom function. So I created my custom thing. It's like a pause, like it's the same like the pause in the Gatling. It makes a pause between your calls. Also, some long values also supported here in milliseconds. And also, I created my test keyword that could be used in my scenarios, and it's also prints out the data with all pasted in variables in here in this format. And also it have before and after function that would be executed after the test that would be called in your scenario, and many other things. It also could execute to create your loops and to make loops and many other things. So the developing the custom engine should be grouped to, maybe should be added to some another chapter, and we should make some another webinar for that, because it's too long to describe how to do that. But just trust me that artillery is extremely hackable. You could do anything that you want. Also, artillery allows you to write such plugins like to get access to your test configurations. For example, here I have some capacity test configurations, which describes the environment and the faces of arrival users. And also it have own thresholds. Also in my custom plugins that I wrote here, I created my own ensure shutdown plugin, which get access to the thresholds. And also I'm adding here the shutdown keyword under the conditions or thresholds. So it could be added somewhere here to every threshold or condition. And also if the condition is not executed or the threshold fails, it automatically stops the artillery scenario and the whole test. So it's extremely hackable. So you could also use artillery to write your own custom plugins to get access to the events of artillery. Artillery have many events. In this case, I have events like with name stats. It describes how artillery gets access to your scenario when it's running, and it executes some JavaScript code every time when your statistics is print out to the console. So every 10 seconds. And also, but this is not the end. The artillery allows you to do everything in your script, to get access to every part of your script, and and also you could also write your custom before and after functions to every call and many other things. So that's extremely hackable, and artillery also allows you to make your custom metrics to be output to any monitoring system that you want to use. So you could realize any crazy idea in artillery. So that's the most biggest advantage of this tool. So we will try to switch back to our presentation. 1 second, I will switch back to here. So, as we can see that K6 is a great and a very popular tool, and it has many advantages. But not everything is not so obvious with the K6, because K6 cannot be compiled using the Webpack with some important Node.js libraries. In this case, for the short time perspective, in the global IDE, exactly, I chose artillery as a main tool because there is a lot of JavaScript security SDKs and modules that need to be installed and integrated into the artillery test and integrated to the test solution. And also, to be able to extend the K6, you need to be prepared to learn Golang. But there is a little remark here that artillery K6 in the last versions said in his release notes that in the future versions they are planning to support some native JavaScript modules. It gives a lot of freedom. So This new feature that I'm expecting from the new K6 versions to support native JavaScript modules would be like a killer feature for artillery, because seems K6 will allow to work with any JavaScript module. So I think we will see. Will it be a killer feature for artillery or not? But we will see if they will be able to do that. And also in this case, it is not the best solution for the startups, which are using different security and cryptography libraries and crypto wallets. As a workaround under this problem, also I'm trying to do that now in my project. You could also build around the K6 like utility services, which would be like a mock services, which would be trying to does all these things that the K6 could not do. The generation of these keys, also generating and decrypting values, encrypting values, and working with all these security and crypto libraries. Also could be, all this logic could be removed from the K6 solution to delegate to other web service, custom web service that could be written by the QA engineers. But also could probably in the future, this custom web service could become the next bottleneck in your system, in your scenario, because it's also when you're scale it up to maybe 10,000 users, it should also have a lot of resources for those utility service to be to support normal working with a normal, very short response times. So here is the biggest minuses of the artillery. So the biggest minus of the K6. So what about the artillery? As I said, and I show you that artillery is super hackable and flexible. So you could again, it's very easy to start writing plugins and scenario extensions. You have a full access to your scenario lifecycle, metrics, and artillery itself. And also it's easy to start writing scenarios, but the K6 also have a lot of minuses. Artillery is also, as it's not so popular tool, the fixes on this repo of the core artillery library doesn't happen so much faster like in a K6. And it's also have a lot of issues in the core and plugins code base. Also creating engines and plugins is not very well documented. That's a biggest minus, because as I said, you can do anything with artillery and get access to all your scenario lifecycle, but all this stuff is not well documented. And so the scenarios are too declarative and are described in YAML format. So why the biggest minus? Because my production scenario for one of the business scenarios when I in my real project is very heavy. So it have maybe more than 1,000 lines of YAML. The YAML file is bigger than more than 1,000 lines. So it means that this scenario at the end becomes crazy, because nobody could understand what is happening in those YAML scenario besides you, because it could be supported by just one developer. Also, it doesn't support scripting and development on pure JavaScript. So it would be like a killer feature for everybody if the artillery will allows you to do the same stuff as a K6, to write to make your scenario with the scripting on JavaScript. Artillery could be also extended just from the big variety of plugins and engines, but not all of them works as expected. As I said, that every time when I'm getting some new plugin for WebSockets or something else, every time I'm meeting some new problem, then artillery could not support using two protocols together in one scenario and something like that. And every time you should override your own bicycles over your scenarios and to extend the artillery with the next new plugins. And at the end, it becomes like a very huge dinosaurs, which gets too much resources and CPU resources at the end. So that's also one of the greatest minuses of the artillery. So, and finally, I would like to say that there is no perfect solution or silver bullet, because tooling does not prevent you from the wrong results. I would recommend using the both of for the different goals. In my project, I'm planning to use mostly artillery to continue using it for usual testing purposes, and data preparation, and K6 for some other scenarios that that need to be redesigned, or in more simpler way, or to be used in those cases when we need to get to make a more smaller resource consumption. So to have the test results that are closer to emulates a production traffic, I recommend you to focus on your non-functional requirements and your goals. Plus, you should have a correct load profile to be able to emulate more realistic traffic and predict the future bottlenecks and problems. For those who are on the early stages of project design, I strongly recommend to inject performance testing earlier as much as possible, as it can help with finding some some issues and services in the services logic, problems with the infrastructure, with the database queries, and the problems with the infrastructure configurations. And actually, Blaze got that in my project. They hired the performance engineer on the most early stages of the features designs, and we are trying to run some performance test experiments under some new features on the most earlier steps, beginning from the dev environment, and then after rebasing to the target test performance test environment, which is used for performance test experiments to to try out this new feature in the new and at scale, and how it's how the infrastructure reacts and how it's scalable with the feature. And also injecting the performance testing culture. I recommend you to inject the performance testing culture to the whole team, and delegating some performance testing tasks and to the backend developers. Why? Because the performance testing process takes a lot of time. So, and I recommend you to delegate some performance testing tasks to somebody else to does some benchmarks themselves to make it, because it make a huge impact to the whole product quality. And also you should also inject those solution and those culture, and to help the developers to run those benchmarks themselves. And also performance testing is connected with a huge number of challenges. That's why don't be afraid to ask your DevOps engineers and backend developers to collaborate with them. The key point, the most critical key point in with this collaboration. So many things could be solved on this phase when you are running your experiments, where you collaborate at the same time with the DevOps, with the developers, to know some nuances and aspects of your system and architecture, because the whole product and to understand how the product performs, this is the whole responsibility for everyone. And so, and I have a final bonus slide for you. So at the end, we could try to cover the most frequently met by me mistakes by the beginners. Sometimes some engineers comes to the social media with their question, what correct tool should I use for that for that task? And I'm telling them that whenever what tool will be used, you will get wrong results and invalid numbers. And after that, I'm giving them this list of mistakes that they should avoid in their practice to get the results which will be closer to the reality. So the first of them, run hammering. Well, let's make a very short slide overview of all these points, and we will finish. Hammering the random endpoints. This is one of the most commonly used mistake, because this is just a waste of time, because it's not showing you the real bottlenecks and problems. But it's not full evil, because it could be used sometimes for every simple endpoints benchmarks. Using very long and complex user flows in the scenario. This is rarely used, but sometimes engineers made a very long, complex scenarios, including the endpoints for some HTML pages, some static, anything else, for some third-party services for that that are integrated outside from outside to your system. Which there is no sense to call. And I recommend to focus more on the scenario simplicity and to leave just the endpoints and calls that made just the key point workload. Creating a load profile from end-to-end scripts or suggestions for colleges. Sometimes your colleges can be wrong with the recommendations, because the difference of expected and actual workload on production is absolutely different. I'd recommend to have the alternative sources of information when developing your load profile and test scenario. It could be the manager's analytics or requests monitoring on the side of your API gateway or load balancer, which gives you the information about all the traffic that comes from the outside. And the next one, creating a load profile from the short time range, 1 to days. To build the needed load profile with the correct request statistics is important to, it is very important to analyze what was happening in your backend from 1 week or till 1 month. Everything depends on the fact who will use your application and at what time the load peak will happen. But depending on the product, sometimes there is no sense for traffic to be analyzed for very long period of time when your product is not still used in thousands of million users, or it is not exposed to production. Like in my case, I'm not mostly on my practice in the globality. I'm not making a very long analytics about the production traffic. Why? Because the product still doesn't have a lot real users, and the product is mostly used by the test engineers and developers, and so the traffic and the character of those traffic change every week when some new feature could be exposed. Testing in the browsers. This is my favorite one, and also one of the most commonly used. I don't recommend to use browsers in performance testing, because it's a very expensive idea to set up thousands of the browsers, and also it doesn't give you the needed information about failed requests, crashed services, and how your backend responds. And also the end-to-end scripts are much more flaky, so there is a high chance to get some failed scenarios with the wrong reasons. But it's not a fully evil, because sometimes there is cases that could be emulated just from the interface. In this case, it will be easier to set up the browsers. Everything depends on the context and what solution will, depending on the solution, that will save your time. And after that, creating scenarios from recordings without data parameterizing to be able to emulate the real users. Each of your parallel threads should work with its own context. So in this case, scenarios should be parameterized, and they should be using absolutely different data in different contexts. Running the test in the same time zone or data center as your application. It's also one of the commonly used. My device always pay attention to where the real traffic is coming from and where will be the most of your target auditory. Testing with the databases, with the database which is empty or much lighter than the production one. In the most cases, your numbers of the response times depends on how many data we have in the database tables. Requests to the empty databases could be more than 10 times faster than comparing with a full field database on production. So that's why only just one this factor could could lead you to absolutely wrong results and wrong numbers of response times and latencies. Testing with the difference between production and test environment configurations. The test will show you how wrong. The test will show you wrong problems, some problems and bottlenecks in the system when the production and test environment doesn't have the same hardware or architecture configurations. So the difference could be just in the number of the scaled services. So in production, your production and test environment should have this absolutely the same configurations of the hardware, of the load balancers, of the databases. So that I think there is a sense just to decrease the number of the scaled services that are used there, or to use more lower database size or memory capacity for the message brokers. And no more reasons are not coming in my head. So testing in production without agreements or when environment is busy, it could also affect your results when your products have unknown visitors at the same time when you're running your tests. Testing without any goals and result checklist. Every test should have its own exit criteria and goals to be able to make the right decision about your results. Testing without application side monitoring. So as I mentioned before, application side monitoring is 15% of your success. It will be like a black box testing without it, because sometimes the overall throughput that you're the understanding of the overall throughput that you're getting on the client side can tell you nothing. So, and finally, in this presentation, I will attach some useful links here, and you could use there in your practice. Here you have links to artillery documentation or K6 documentation. Also, I have links to the artillery and K6 sample projects that I used, that I use here. So you could use them anytime. Also, you could use their the examples of the dashboards that we that are built for K6 and artillery, for Datadog, for Grafana. I have many examples there. Just get it and enjoy. So, and thank you for joining. And if you'll have any questions, I'm waiting for you and I'm waiting for your questions. And thank you for joining and for your time. Hope that my experience will help you with choosing a correct tool for correct and to make the right decisions without wasting a lot of time in the future when you have the same situation like mine, when you have when you want to use some tool on JavaScript. So
yeah, we have also questions in the chat, but please, before answering, read the question and then the answer. So we will have everything on the video, and people who will see it will understand everything we are talking about.
1 second. The first question by Yaroslav: what instrument, in your opinion, is more useful for fighting the bottlenecks? So, as I mentioned earlier, then the tool does nothing. So the K6 or artillery doesn't prevent you from the wrong results. And so the bottlenecks could be found using the both tools, but just with the right business scenario or load profile. So for Yaroslav, I would recommend to focus more on analyzing the traffic, the production traffic, or the building a correct load profile and building correct scenario and with the needed business flow that will emulate the production behavior, the user's production behavior. So the both could be used for that, but I'd recommend to focus on the load profile and which could also guarantee the finding of the needed bottleneck, because if you will not use the correct load profile, you could find the wrong bottleneck that could not be reproducible on the real production. And actually, so the situation is it. So let's try to read the next question. Olena, are these tools suitable for all performance testing types? Yes, of course. K6 or artillery has a very flexible configuration. So and K6 and I think the K6 have a bit more flexible configurations than artillery because it have different types of creating and the open and closed model workload models. So you could use many different features of the K6, how to describe your load plan, and I think the K6 have a lot more sugar in this case when creating a scenario configuration and describing the load plan rather than artillery. But the both could be also useful for used for any kind of performance testing, capacity tests, stress tests, load tests, stability tests, SOC test, or any others, volume tests. But you need just to focus on those. Also on those facts, depending on what intensity you should also generate to your target environment, you should use the right tool, because you should know that the K6 aids much less resources than artillery. And yeah, so it could be used any, but I'd recommend to look first at the K6. I think yes, but if the K6 also could not be used for your goals, you could also migrate to artillery. Or if your solution have such very specific protocols and libraries that could be joined, and if you want to create any new protocol and to be used in your load test, I'd also recommend artillery, because artillery gives you all the freedom to do everything, all this stuff. So the next question from the Sergey: do you recommend these tools for the high load apps testing? Actually, the high load apps testing needs support of the building a distributed cluster. So this solution. So comparing these tools together, K6 have I will show the K6 have the Kubernetes operator that allows you to deploy a free distributed K6 cluster in the Kubernetes, and also it allows you to scale up much more the load, and it also takes less resources. And also artillery also has an artillery operator. It's an implementation of Kubernetes operator for artillery, which also allows you to deploy a free cluster of artillery into your Kubernetes cluster. But you need to compare them together. You should know that artillery takes a lot more CPU resources. So first, you need to decide what tool is more suitable for you to write the scenario, and what would be what could be easier. And the both of them have its own Kubernetes operators to be deployed like a distributed cluster into the Kubernetes. So, and artillery also could also be deployed as a separate agents on different virtual machines, and it's also you also have access to all the metrics for each of these agents. You can then group together all these metrics to create your custom metrics to be grouped together and to be counted in the right way. So so yeah, I'd recommend for the high load projects, I would recommend K6, not artillery. But if the artillery is your only way, but you can also deploy it in a distributed mode using artillery operator. So the next question. What are the advantages of these tools in comparison with the JMeter? In the practice, I'm seeing that the biggest advantage of this tool that the code base of the scenarios are keeping in your usual version control system, like GitHub, GitLab. Also, these scenarios could be reused by the most of the developers. And also, you could also make some educational events for the developers to make them learn how to write themselves those performance tests and scripts. So, and sometimes it's much easier to realize some ideas, to write some more complex scenarios with the different types of the loops and if conditions. We're using just JavaScript or using some features of artillery. So the scenario would be much more shorter and much smarter than. So the problems in the JMeter with using JMeter begins when the scenario becomes very big, and so it's much easier to have complex and huge and very long scenarios in the K6 or artillery. And the next question, can I argue about some of the anti-patterns? Sometimes it depends on the context. We could also try giving a voice to the Sergey if he want to argue some of the anti-patterns.
Yes, okay, I can unmute you. So if you want, you can have a discussion, maybe discuss it a little bit. Give me a second. Yeah.
Hello, everyone. Thanks for the presentation, Savva. I can say that if you have some kind of applications which has a lot of configurations, for example, some kind of platforms, and you have a lot of production servers, sometimes it's really tough to have a lot of configurations or a lot of test environments. So you can check your performance of your code on some basic configuration, on some basic hardware configuration, and you can track over the releases the performance of your code to check if you have some kind of degradation in performance and so on. But if you have a goal to test prod environment about some kind of load, I agree with you. So we should have a product-like environment, but sometimes production service has a really huge configuration, and it's take a lot of cost to set up such kind of environment. And probably it's really tough to have this configuration. So
right,
it can be this can be some kind of patterns when you have non-production environments for the load testing. Thanks.
Yeah, no, here I agree with you, because sometimes on one of my last projects, I didn't add and separate test environment for performance testing because all the money were spent for setting up the production. So, and that's why they were not able to support the same kind of test environment with the same SSD disks for the databases, because the most of the money they were spent for this for building the database server for this very expensive disks for some expensive hardware that allows you to handle a lot more load, and so they were not able to spend more money for building the same environment. So here I agree with you that sometimes yeah, you have no ways just to test on production, and but it have also but this kind of testing is also very specific. Then you would also be very involved in the traffic monitoring on your production, because you could just provide your performance tests. You could also try to implement different deployment strategies, canaries deployments or something like that to your infrastructure to test some new deployed services that are not exposed to the outside. Or you could also test your production backend from the load balancer when you have a minimal workload on your production. For example, if or the real people are using your product, when everybody in the target zone are sleeping, you can just running your performance tests there in those time. And there are many other also interesting mechanism how you can do that. So this is also a very interesting topic, how to run the performance tests on production. And sometimes you have no ways, because sometimes all the money was spent to the production, and there is no adequate the environments that could just be a replica of production. Yeah, that's a good point that you mentioned.
Thank you.
And
Okay, any more questions?